Hello, welcome to my presentation. I am Yahiaoui Adel, teacher researcher at the University of Media. Within the framework of First International Conference on Sustainable Energy and Advanced Materials, I have the honor to present my work entitled Optimization, the Design of Hybrid Renewable Energy System using Homer Software. This work is carried out within a research laboratory of Electrical Engineering and Automatic, University of Media, Algeria. The work plan can be summarized as follows. I start with an introduction which explains in general why my work, the selected site, system study, result and discussion, and finally a conclusion. In all countries of the world, electricity is more essential than ever for economic development. Its importance increases with technological developments, industrialization, and the need for modern comfort. The increase in its production is therefore synonymous with an increase in the quality of life and the creation of the wealth. In the work presented, we provide electricity to a small isolated village in the wilaya of Gardaya. The location of the chosen sites for our study is presented in Figure 1. The city of Gardaya is located in the north of Algerian desert, 600 kilometers south of Algiers, with a total estimated array of 86.105 kilometers square, from north to south of 415 kilometers, from east to west from 200 to 215 kilometers, from sea level to 486 meters. In the present case, a photovoltaic diesel battery hybrid power system and a power converter is used to design and meet the load requirements of the village under investigation. In this study, we present a novel approach for optimizing the size of hybrid renewable energy system. The configuration of hybrid photovoltaic diesel system chosen for our study is presented in Figure 2. Here, the diesel generator is interconnected on the alternating current bus, and the photovoltaic system and the battery are linked on another direct current bus. The two buses are connected using a bidirectional electronic converter which can work either as a rectifier. In this paper, optimal sizing of hybrid renewable energy system using Homer software is presented to determine the optimal configuration of PV panels, diesel generators, battery banks, and minimize the total annual cost of hybrid system. The Homer software and the irradiations values and characteristics of measurement site, the evaluation of monthly sunshine for the month of January and July is illustrated as shown in Figure 3. Note that the irradiation values for January range from 0 to 710 kilowatt hour by meter square and from 0 to 1028 kilowatt hour by meter square, increasing for July. For the temperature of Gardaya, in the same way, we obtained from ONM the monthly values for January and July. The graphic visualization represents the monthly temperature variation as shown in Figure 4. We calculate the amount of electricity needed to cover the electrical needs of the village with a thorough study of all the electrical instruments used, which is represented by the amount of electricity consumed and the hours of operation through 24 hours, day by day and hour by hour. The number of electrified homes is 20 homes, school, clinic, and public lighting. These equipments are operated by a single-phase system. The Figure 5 is represent the hourly load profile for month of January and July. The choice of the optimal configuration by Homer software depends on the net present cost, which must be minimal. The different value of cost for hybrid renewable energy system for month of January and July are presented in table 1 and 2 respectively. Using parameters obtained from the optimization using Homer software, the annual cost system could be minimized to $255,620 for January and $210,052 for month of July. In this paper, we proposed a hybrid renewable energy system for electrification of rural city from south of Algeria. The results obtained from the Homer in our case study gives the optimized initial capital cost is $181,599. Total cost system is $255,620. Cost of energy is $0.157 by kilowatt hour from month of January, and total cost system is $209,952 with an initial cost of $167,969 and cost of energy is $0.075 by kilowatt hour for the month of July. The price of energy of the optimal system is lesser than the grid provided cost of energy for the two cases studied in this work. A lot initial cost of PV diesel battery hybrid system is high, but its electricity at lesser cost. And thank you for your attention.